In Form 2, we learned that chlorine is an element in periodic table with atomic number of 17 and mass number of 35. Chlorine is a nonmetal which gains an electron to form chloride ion. Chlorine gas is a diatomic and is prepared in the laboratory by action of concentrated hydrochloric acid with potassium manganate 7. Note that chlorine is poisonous and should be prepared in fume cupboard or well-ventilated room.
The following video clip shows preparation of chlorine gas. This experiment is usually done in a fume chamber or in open space because chlorine gas is highly poisonous. The reagents used in this experiment are concentrated hydrochloric acid, potassium manganate 7 crystals. The apparatus used in this experiment are gas jar, boiling tube, cover slip, thistle funnel, delivery tube, cork, flat-bottomed flask, clamp, and finally, the gas mask.
Five to 10 grams of potassium manganate 7 is placed in a flat-bottomed flask. Add concentrated hydrochloric acid dropwise and allow the reaction to occur.
The observation made from the experiment indicate that chlorine is a yellow-green gas. It has unpleasant, pungent, and irritating smell. Chlorine is fairly soluble in water. It is also denser than air, and that is why it is collected by downward delivery or upward displacement of air. The gas is passed through water to dissolve hydrogen chloride gas. This is highly soluble in water. To collect dry sample of chlorine gas, it is passed through concentrated sulfuric acid. Chlorine gas reacts with metal to form metal chloride.
The following video clip demonstrates some of the properties of chlorine gas. Magnesium ribbon is first cleaned using a sandpaper.
Magnesium ribbon is cleaned using sandpaper to remove oxide coating on it, formed after a long time exposure in air. On burning magnesium, it produces white brightly flame. On placing it on gas jar containing chlorine, it continues burning brightly, forming a white solid. Conclusion: magnesium reacts with chlorine to produce white solid of magnesium chloride. The equation for the reaction is written as follows. Iron reacts with chlorine as shown in the following animations. Chlorine reacts with hydrogen sulfide. The following animation shows the reaction. Observe what happens carefully. Chlorine oxidizes hydrogen sulfide gas to sulfur at room temperature. Chlorine is, on the other hand, reduced by hydrogen sulfide to hydrogen chloride. Chlorine is oxidizing agent and hydrogen sulfide is reducing agent. To understand the bleaching action of chlorine gas, moist blue and red litmus papers are placed in a gas jar containing chlorine gas. Colored flower petals are also placed in another gas jar of chlorine gas. Click to play the following video clip and observe what happens.
The following video clip demonstrates the effect of chlorine gas on moist blue and red litmus papers. Can we use the one that the chair has used?
Yeah, what we'll do, let's give both of them time. Then once they turn, we can use
Turn it slowly. Okay, lift the other, yeah. Like that. The back, look. More. Yeah.
chlorine gas, bleached moist colored substances. Blue litmus paper changes red because chlorine gas is acidic and therefore forms acidic solution when dissolved in water. However, red litmus paper changes to white. Similar, chlorine gas reacts with water to form hypochlorous acid and hydrochloric acid. Hypochlorous acid contains atomic or nascent oxygen. The atomic oxygen is unstable and therefore easily removed from hypochlorous acid in presence of sunlight to form hydrochloric acid and oxygen gas. In the presence of colored substance, the atomic oxygen oxidizes the dye, therefore bleaching the substances. The following video clip shows displacement reactions that take place when chlorine gas is bubbled through different halogen halides. Click to play the video and observe what happens carefully.
The following video clip shows the observations made when chlorine gas is bubbled through potassium bromide solution and potassium iodide solution. The reagents to be used are potassium bromide solution, potassium iodide solution, potassium bromide changes from colorless to brown since chlorine gas displaces the bromide ions to bromine. Potassium iodide changes from colorless to black since chlorine gas displaces the iodide ions to iodine.
Show me the lab. Yeah.
Chlorine gas is bubbled into colorless potassium bromide solution. The solution turns to brown due to formation of bromide solution. Chlorine gas, on the other hand, when bubbled into potassium iodide solution, turns to dark brown solution, and finally, a black solid of iodine is deposited. Conclusion: chlorine is more reactive than bromine and therefore displaces it from its solution to form bromine water. Chlorine is more reactive than iodine and therefore displaces it to form iodine solid. Brown bromine gas also displaces iodine to form dark brown solution and finally black solid of iodine. The order of halogen therefore can be written as The following video clip shows the procedure of testing for the presence of a chloride. Click to play the video clip to observe what happens.
The following video clip shows tests that are carried out to show the presence of chlorides. Sodium chloride solution is made when water is added to sodium chloride salts. Sodium chloride solution is put into a test tube. Add a few drops of silver nitrate solution into the sodium chloride solution and observe what happens. And then shake. Add a few drops of nitric acid into this solution and observe what happens. The white precipitate does not dissolve. This is not a confirmatory test for chlorides. To confirm the presence of chlorides, ammonium solution is added. The white precipitate dissolves to form a colorless solution of a complex ion.
Sodium chloride solution reacts with silver nitrate solution to form a white precipitate of silver chloride, which is insoluble in nitric acid. The equation for the reaction is as follows. Sodium carbonate solution, on the other hand, reacts with silver nitrate to form silver carbonate as shown in the equation. However, silver carbonate reacts with nitric acid to form silver nitrate, therefore dissolving the precipitate. The following are some of the uses of chlorine. Pollution effect of chlorine in the environment. Organic chlorine compounds are organic compounds in which chlorine is strongly bound to carbon. They are highly stable, cannot be decomposed by microorganisms, and therefore remain in the environment for long and are non-biodegradable. They eventually accumulate in body fat of fish, animals, and ultimately in human through food.